All right, our second little part of chapter 4.2, 4.2b is all about scientific notation. Scientific notation provides us a useful way of writing really big numbers or really small numbers in an easier fashion. For example, the mass of the Earth is 6 times 10 to the 24th power. That's multiplying 6 by 10 24 times. If you were to write it out in standard notation or decimal notation, it would look like this. That's a lot of zeros. That's 24 zeros. I can't even fathom how big that is. Or the mass of a hydrogen atom is 1.7 times 10 to the negative 24. That's dividing by 10 24 times. And so that would be 0.000000000000017. That's 23 zeros, 1, 7. That's a really small number. So we can take these really small numbers or really big numbers and write them a little more easily in scientific notation, where the rules are you have to have one non-zero number in front of the decimal. So a single digit non-zero number in front of that decimal. You can see here in the Earth you have a 6, or in the hydrogen atom you have the 1. There is one non-zero number in front of that decimal. For a big number, you have a positive exponent. For a small number, you'll have a negative exponent. You're going to move the decimal the same amount as the exponent and fill in the blanks with zeros. Let me show you a few examples. In example number 6, it says here to convert to decimal or standard notation. We have the number 7.893 times 10 to the 5th power. That means I'm going to take this 7.893 and I'm going to multiply it by 10 5 times. That positive 5 means that I'm going to move the decimal place 5 times, and I'm going to move it to the right. I'm going to make that number bigger and bigger and bigger. 1, 2, 3, 4, 5. And I'm going to fill those blanks in with zeros. So the decimal now is at the back, and I have 2 extra zeros in the end. So my final answer is actually going to be 789,300. That decimal's in the back. It's invisible there, but it's still there. I've moved it 5 times to the right to make that number bigger. Look at B. B says 4.7 times 10 to the negative 8th. That means I really want to take the 4.7 and divide it by 10 8 times. I'm going to make that number really small. I'm going to move that decimal place 8 times, but this time I'm going to move it to the left. 1, 2, 3, 4, 5, 6, 7, 8. My decimal is now here, and I'm going to fill in these blanks with zeros. So your final answer should be 0.000000. That's 1, 2, 3, 4, 5, 6, 7 zeros, and then a 4, 7. So that negative exponent represents that I'm going to have a really small number. The positive exponent represents that we're going to have a big number. So you should be able to take any number that's in scientific notation and put it into decimal or standard notation. You should also be able to go backwards. So can you go backwards on these next two? So example number 7 asks us to take these standard numbers and put them into scientific notation. Remember, the rule is that you have to have one number in front of your decimal, one non-zero number in front of your decimal. So on this one, 83,000, remember that your invisible decimal is in the back, and you need to move it so that there's one non-zero number in front of your decimal. 1, 2, 3, 4 places then I would have to move it. And so I can say 8.3, take off all those zeros at the back, and I can say 8.3 times 10 to the 4th power because I moved my decimal place 1, 2, 3, 4 times to get it to be behind that 8. So 83,000 is the same thing as 8.3 times 10 to the 4th power. The 4th power means I'm going to take that 8.3 and make it bigger, and that's how we get the 83,000. Look at part B. Part B says I have 0.0327, and I want to put it in scientific notation. Remember, we want to take that decimal and we want one non-zero number in front of it. So I'm going to take this decimal, I'm going to move it 2 times so that it can be behind the 3, change my number into a 3.27. And how many times did I move the decimal? Twice, right? But remember, that number was really small. So I want to make sure that I move it and say that my exponent is a negative 2 to represent that it's going to be a small number. We're actually going to divide by 10 twice. So 3.27 times 10 to the negative 2. All right, make sure you know how to take a standard number and change it into scientific notation. Also, make sure you know how to take a number in scientific notation and convert it back to decimal or standard notation. practice a few of those, and in the next video, we'll talk about a few operations with scientific notation.